Okay, so I'm going to do this problem, and I haven't actually ever done it before, so you'll be able to see my thinking and my mistakes as I do it. But I know I have a height and a radius, and the height and the radius are the same. This theta is theta. Alpha is this part here that's been cut out. Okay, and so I want to find this value of alpha so that the volume of the cone, the volume of this modified cylinder are the same. Well, I know that the volume of the cone is 1/3 pi r squared h. Okay, and so now I need to find a formula for this volume. Well, I know for the volume of that cylinder, I know it's going to be the base area, which is this funny sector, times the height. So let's work on this base area. The base area, we know the formula for area of a sector is half r squared theta. And this whole thing angle here is going to be theta because that's the area I have. So theta then is going to be 2 pi. I'm going to do it in radians because this form is a radian formula, minus alpha. That's what this area here is. And so my base area is going to be half r squared 2 pi minus alpha. And so now this volume here of 1/3 pi r squared h is going to equal to the base area 1/2 r squared 2 pi minus alpha times h as well. And so now it's a matter of solving for alpha. I can come along here, the r squares cancel, the h's cancel. I'm going to multiply by 2 and by 3, so I get 2 pi is equal to 3 times 2 pi minus alpha. So 2 pi is equal to 6 pi minus alpha. Subtract this over, and I get minus 4 pi, equals minus alpha. Alpha equals 4 pi, that doesn't make any sense. Alpha equals 4 pi. The volume, wait, something's not right here. Oh, I gotta make this is a 3 alpha, and so it's 4/3. So alpha equals 4/3 pi, or 4/3 pi. That sounds better to me. So in order for these to be equal, I solve this equation and I get alpha is 4/3 pi. So it's definitely not drawn to scale. So there's A part. Okay, so moving on to B part, for this value of alpha, we need to find this theta here. So the lateral areas are the same. And so the lateral areas for a cone, well, if I look at my formula booklet, oh, that's not my formula, that's the answer. Here's my formula booklet. Here is the curved surface area, it's pi RL. And so I know that this area is pi RL. And so now to find this area, I need to find this curved part plus these blue regions here. So in order to find this curved part, when I open this whole piece up here, that length, that arc length, I'll call capital L, is with this height makes a rectangle, and then I have to add these two pieces on. So that big L is equal to r, theta is the formula, but theta, I know theta is 2 pi minus the 4 pi by 3. It's 2 pi minus 4 pi by 3, which is, this is 2 pi by 3 times r. That's the length of this. Now, the area is going to be 2 pi over 3r times h to get the rectangle. But then I'm going to add this and this, so then there's going to be two little rectangles there, 2 r times h's. And so this area has to be the same as this area, and I'm trying to find theta, which is here. Okay, so if I set them equal to each other, pi RL is equal to, and if I look in here, I'm going to factor out an RH. It's going to be, and the 2 as well, so 2RH times, if I factor that out, I'm left with a pi over 3 plus 1. 2RH, I get a pi over 3, and a 2RH is 1. Solving this, I can, what can I do? I'm trying to get theta, remember? So I can get rid of R. And so L, a little messy, L is equal to 2H divided by pi times pi over 3 plus 1. That's, this length here is going to be 2h over pi times pi plus 1 is this length here. Okay, and so then if I'm trying to find theta, well, theta is equal to sine of theta. Here's an h and here's an h, so it's going to be equal to h over sine h over pi times pi plus 1. And so these h's cancel away. And so there's a 1 on top here. And if I put this into my calculator now, if I find my calculator, if I go to my calculator, I can make it a bit bigger. Done. Okay. So if I go second sine, I'm going to go 1 divided by, and I'm going to put in parentheses so it's all on the bottom. Double parenthesis, 2 divided by pi, close it. Then I'm going to open it, a pi plus 1. Enter. And so I get 22.3 degrees. So I get theta is equal to 22.3 degrees. It's messy algebra in there, but it all seems to work out.